Hey, what do you see when you look into your kaleidoscope? Do you wonder how it works? Let's find out. Stand two mirrors about 12 inches apart. Any kind of mirrors will work here, but it's best if they're not in a frame. Mirrors should be small enough to move easily. Now, place an object between them. How many reflections do you see? Let your students spend some time exploring by adjusting the distance between the mirrors and changing other variables, such as the angle of the mirrors. Next, we're going to link two mirrors together by creating a hinge. Tape two mirrors together like this. The tape will form a hinge. Now, a protractor will be a really cool tool to use here because it will help you measure the relationship between the angle of the mirrors and the number of reflections that you can see. Tape the protractor on the table like this. You want one of the mirrors to run along the straight edge of the protractor. See the 0 here? Put whatever object you'd like to use between the mirrors and note the number of reflections as you change the angles by moving only one mirror. Keep the other mirror along the straight edge of the protractor. Use the protractor to measure the angle of the mirrors at various positions, reading the angle numbers that are on the inside of the protractor arc. What's the fewest number of reflections you can make? At what angle do you get the largest number of images? Remember, we measured the angles of the mirrors in our kaleidoscope. Find that angle with the mirrors here. How many times is the object reflected? Does this jive with what you're seeing in your kaleidoscope? Why or why not? If you have older students, try this challenge. You can predict the number of images that you will see at any angle by using the following formula. 360 divided by the angle, say 40 degrees, then subtract 1. Here's another idea to try with a single mirror. Give students half a sheet of paper and have them write out one or more of each of the following symmetrical letters. U, V, E, T, X, Y, M, D, C, A, O, W, B, H, and I. You can also include a few non-symmetrical letters, like Z and N. Ask students to continue their investigation with the mirrors and these letters. Can you hold your mirror in a way that you can see the other half of the letter? Can you make the letter look differently by holding the mirror along different parts of the letter? Can you find a line of symmetry in all the letters? Are there any that you can't make symmetrical?
Changing the Equation, after-school math curriculum brought to you by Explora. Funding provided by Sandia National Laboratories. Find more Changing the Equation videos at explora.us/changing-the-equation.